Now we're going to talk about something that some of you might have seen before and some of you might not, and it's something called log properties. These are just like when you learned exponent properties back in middle school. One way you can remember exponent properties is the acronym MADSEAM. And that's going to help us remember that when you multiply the same base, you add exponents. If you divide the same base, you subtract them. And when you raise an exponent to an exponent, you multiply. With log rules, it's kind of like we read it backwards. When we multiply the same log, we can raise it to an exponent. When we subtract logs with the same base, we can divide. And when we add logs with the same base, we can multiply. So we're just going to go through those a step at a time. But that MADSEAM and then going backwards with log properties, I think could be helpful. All right. Let me finish erasing. So we'll look at the first one. Our exponent rule is that when you multiply the same base, you can add the exponents. So if I have a to the j times a to the k, it would be a to the j plus k. We go in reverse for the log rule. In the log rule, if I am multiplying two things in my argument, I can rewrite it by writing it as the sum of logs with the same base. So log base b of j plus log base b of k. When we're making it bigger like that, it's called expanding, and if I went from this side to that side, we would call that condensing because we're making it smaller. So some of you are skeptics out there, so let's prove this numerically. So we want to show that log base 2 of 4 times 8 equals what I know it should, which 4 times 8 is 32, and what power of 2 is 32 would be 5. So if this property actually works, we should end up with the answer 5. So we're going to split it up. When you multiply two things in your argument, you can split it up with addition. So log base 2 of 4 plus log base 2 of 8. Remember, a log just means an exponent. So what power of 2 gives you 4? 2. What power of 2 gives you 8? 3. And we do get, in fact, that 2 plus 3 is 5. So our property works with a numeric example. So now with our next exponent rule, when we divided the same base, we could subtract the exponents. So a to the j over a to the k would be a to the j minus k. We would subtract the exponents. Now if we start with division, I can split it up into subtraction. So log base, keep your base the same, whoops, log base b of j minus log base b of k. And let's show that numerically. So 8 divided by 4 is 2. So log base 2 of 2, what power of 2 is 2? That's just going to be 1. So let's check that. Log base 2 of 8 minus log base 2 of 4. What power of 2 is 8? 3. What power of 2 is 4? 2. And 3 minus 2 does give me 1. The last exponent rule you used a lot was that when you have an exponent raised to another exponent, you multiply the exponents. So a to the j raised to the k power is just a to the j times k. And now here, if I have an exponent outside, we're going to bring it in front like multiplication. So that's going to be rewritten with the k in front, k log base b of j. So numerically, let's check that. Log base 2 of 4 cubed is 64. What power of 2 gives you 64 is going to be 6. And let's prove that. So we have 3 log base 2 of 4. What power of 2 gives you 4? 2. And 3 times 2 gives you 6. So let's look at some examples. The first, oh, just kidding. We're going to have to do a change of base. Luckily, all these problems had JK, so we're going to say we JK'd on that. So our calculator doesn't really like to do anything that's not a base of 10 or a base of e, which would be natural log. And so it can be helpful for us to know this thing called a change of base formula, which is if I have log base j of k, I can do log k divided by log j. And if I don't write a log, then it's understood to be base 10, which is really nice for my calculator. You could also do natural log k over natural log j, or you could choose your favorite number. So if we want to do base 2, log base 2 of k over log base 2 of j. All of those would give me exactly the same answer, but we'll usually use one of these two because that's what our calculator talks in. So let's show this one. So log, and let's use base 2 because I can do both of these in base 2. Log base 2 of 32 divided by log base 2 of 8. So what power of 2 is 32? That's 5. What power of 2 is 8? That would be 3. Which is the same thing as saying 8 to the 5/3 power equals 32, which is true. So now we're going to do the first type of problem you'll be asked to do with log properties, which is to expand. That means to basically write everything expanded out. So the first thing you need to do is kind of identify what's in the problem. So what I notice in this problem is that the 27 and the x are connected by multiplication. And when they're connected by multiplication, that means I can rewrite it as an addition problem. So log base 3 of 27 plus log base 3 of x. And what I notice here is that this is going to be just a number since all I have are numbers, no variables. So what power of 3 is 27? 3. 3 cubed is 27. So 3 plus log base 3 of x would be my answer. We start getting more complicated in number 2. The first thing I notice is that I have multiplication again between my y and my x. So I'm going to start with that and do log base 5 of y to the 5th plus log base 5 of the cube root of x. Now what I see is that both of my variables have exponents. So what I'm going to do is bring those exponents out. Now you may not remember, but the cube root of something, the cube root of x, is the same thing as x to the 1/3. So when I bring that out front, I'm going to bring out a 1/3 because something, the cube root is 1/3, square root is 1/2. Those are some handy things to know. And I'm going to keep everything else the same. I don't have anything that I can evaluate in that one because all I have are variables. So we're going to move on with our life. Got something a little more complicated. This one I noticed we have a fraction, so that means division. And there's a couple ways you could do this. You could use parentheses, but what I'm going to do is I'm just going to write it as log x plus 3 squared minus log x. And then I'm going to say minus again log y to the 4th. Once again, you could put parentheses and put plus in between the x and the y to the 4th, but I like to do it just both subtraction. Now I'm going to look for any exponents that I can bring to the front. So I have a squared that I'm going to bring to the front, and that 4 that I'm going to bring to the front in the next line. So 2 and 4. And then I copy it down, everything else I have, and we're good to go. Now, someone out there really, I'm sure, is tempted to try and kind of distribute this log to the x and the plus 3, but you cannot distribute log. It's a function. It's not something that I can distribute. So we're just going to leave it. Okay, holy moly, look at this one. All right, outside everything I have an exponent, so I'm going to deal with that first. 3/4 natural log of all that junk. And what I'm going to do is put that 3/4 out front with a nice set of parentheses. And then kind of treat it like the problem I did before. So I'm going to do 3/4 times natural log e to the 3rd plus, because I have multiplication, plus natural log of x minus 4 minus natural log of x to the 4th minus 1 squared. Woo! Okay, let's simplify some of this. So the first thing I'm looking at is that natural log of e cubed is actually just all going to reduce to 3. Because remember, natural log is base e. So e to what power is e to the 3rd? Well, just 3. The other thing I see is that I have an exponent still left. So when I go to the next step, I'm going to bring that to the front. So let's write the next line. 3 to the 4th times 3 plus natural log x minus 4 minus 2 natural log x to the 4th minus 1. And the last thing to do is distribute your 3 to the 4th. So that's going to be 9 over 4 plus 3 over 4 natural log of x minus 4. That's a 4. There we go. Minus 3 over 2 natural log of x to the 4th minus 1. So as you can see, expanding really kind of starts to take up a lot of room. But if you take it step by step, it's going to be okay. And this last one, don't forget that something that's the square root is the same thing as being to the 1/2 power. So I'm going to bring that to the front. 1 over 1/2 natural log x, and we don't really like to have fractions in a denominator, and when I multiply by that reciprocal, I'm going to get 2 over natural log x. What's important to know is that this is not equal to 1 minus, let's see, what might you think? Natural log square root of x. No, not that. So just be careful that just because it's a fraction, you're looking for the fraction to be in the argument, the kind of inside of the log, not for the entire problem to be a fraction. Okay, let's go the other way, which is a lot happier because we're going to condense it and make it a lot tinier. So what we want to start with here are these exponents. So if I have a coefficient of my log, that's going to come inside as a exponent. All right, so that gives me log of x to the 5th minus log y to the 1/2, which is just going to be rewritten with division, log of x to the 5th over y to the 1/2. And remember, something 1/2 just means square root, so we could rewrite that also as x to the 5th over square root of y is also an equivalent statement. The next one, let's start with the inside of the parentheses here. So I notice I have this 4, which is going to come inside as an exponent, and also that I have subtraction, so that means it's going to be rewritten with division. So log 2 log m minus 3 times, I'm going to condense all of the stuff on the inside of the parentheses, log of k over m to the 4th. And now moving outside the parentheses, I'm going to bring this 2 in as an exponent. This 3 is going to become an exponent for everything inside. So that will give me log of m squared minus log of k over m to the 4th, all raised to the 3rd. And the last piece is to rewrite that with some division. So log of m squared, ew, we're getting such a big fraction. We're definitely going to need to clean this up. Over, I'm going to distribute that. So we're going to have k cubed over m to the 12th. Change that to multiplying by the reciprocal. So we're going to have m squared times m to the 12th over k cubed. So final answer, we'll put that in pink. Log of m to the 14th. 14th, you got that? Over k cubed. All right. And this is our last problem. So we have a -1 in front. That's going to come in as an exponent. Remember, when you have something like, excuse me, the square root of 3, then if I do it to the negative power, that's going to make it 1 over the square root of 3. So natural log of 1 over the square root of 3. And you know, someone somewhere decided we shouldn't have square roots in the denominator. So we have to rationalize that. Everyone's favorite thing in the world. And our final answer is square root of 3, natural log square root of 3 over 3. That's it for log properties.